So now we want to start to talk about crossing the membrane. And in this very brief recording, I want to talk about, emphasize the idea of membrane selective permeability. And this is not something I haven't said before, but it comes down to the proteins in a membrane that are going to dictate what things can cross that membrane. Now, it's incredibly important because a closed system is a dead system. So that membrane, the plasma membrane, must be able to exchange materials with its environment, but it has to be selectively permeable. It has to regulate the traffic across that membrane. So again, the beauty of biological membranes are that they are relatively weak physically. It's soap. It's a lipid bilayer. It's 2 molecules thick. But chemically, it can be very, very robust. And so that's super, super important, and that's kind of the key to how membranes work. And so certain types of molecules just won't go through a membrane, and those molecules are those that are very large and have charge because they want to stay with water. They do not want to go through that hydrophobic layer. So to summarize that, we can kind of think of small hydrophobic molecules are going to certainly pass through the membrane relatively easily. All right, small uncharged, if they're small enough polar molecules, will move through the membrane with some degree of ease simply because they're so small. Now, when we get to larger uncharged molecules, they're not going to move across the membrane. If they're polar at all, or if they're big enough, that membrane is going to be a very, very robust barrier to them moving across. And then finally, anything with a charge, big or small, has great difficulty leaking through the membrane. All right? So small hydrophobic, that hydrophobicity in the interior of the lipid bilayer is not a deterrent. So if it's in the environment, it can relatively easily diffuse through the membrane. Small uncharged or small polar molecules, because they're small enough, can move across. Larger molecules or polar molecules in general, no. Anything with charge, no. Okay? So that is kind of the chemical summary of how the membrane works. So again, how do things move across the membrane then? Because we need to move things across the membrane, is where we have transport proteins. So they're going to allow the passage of hydrophilic substances across. You're going to bypass that hydrophobic core of the membrane. Now, they're oftentimes very specific to what they move. So they can fall into 2 general categories, channel proteins or carrier proteins. Right? So channel proteins basically make a pore, like there's a hole, there's a tunnel that is made of the protein that allows things to move across the membrane, while a carrier protein actually has to change its shape. It's more like a gate that opens on one side and then moves things across to open on the other side. All right? And we'll look at the subtleties of these more as we go on. But then the next question which this begs is, how do things move and what direction do they move? Like, what powers that? So the rest of this membrane talk is going to be about powering that movement, using membranes to create gradients, like that there's more of something on one side than the other. And we have to have a barrier to create that differential. And that differential is the source of all life energy. Right? That is such a fundamental concept in all of bioenergetics, this idea that I've got a barrier. That barrier has to be robust enough to be like, I can create this differential. And we, in essence, are the result of that differential. We'll talk more about this. The idea here is that some things move by passive diffusion. The cell doesn't have to put any biological energy into the system, and things will move down their concentration gradient. And that can be facilitated through a channel or a pore or a carrier protein. Now, in other kinds of movement across the membrane, we have to expend energy. And most biological energy costs are in the form of ATP. So we're going to spend some ATP, move things across the membrane against their concentration gradient. And then finally, this also then lends itself to what's called bulk transport, which is going to be in endocytosis and exocytosis, bringing things into the cell or exiting them from the cell without ever really crossing the membrane, because we're going to make compartments or vesicles to contain the things that we bring across.